Hello, this is Algebra 2. We're in Chapter 8, Section 5. This is page 3 of the notes. We have this first checkpoint, meant to cover some of the stuff we talked about during the first couple pages of notes. Checkpoints 1 and 2 are relatively straightforward, so I'm going to recommend you try number 1 and 2 on your own, both together. I'll wait a few seconds so you can pause the video, then unpause it when you're done. Okay, so if you look at number 1, it turns into just 8x minus 7 over 3 plus x. The denominator is the same. We're talking about 3 plus x for both terms. So 3 plus x is your denominator. And the numerator is just subtract, because you already have the same denominator. 3 plus x, 3 plus x. So 8x minus 7 over 3 plus x. Yay! Now if you look at number 2, it's a little more interesting. First of all, though, the denominators are the same. So you have a 3x and a 3x and a denominator of 3x, and so everybody's pretty happy there. Add up the numbers. 13 plus 2 is 15. Now an exciting thing happens here, though, because 15 and 3 each have 3 divide evenly into them. So the fraction reduces to 5 over x. All right. That's what's going on for 1 and 2. Pretty straightforward, pretty fast, relatively easy. Number 3, however, is not relatively easy. So for number 3, I'm going to strongly recommend that you pause it and get a new sheet of paper and try it yourself. It will definitely not fit in the box. So I'm going to wait a few seconds for you to pause it. If you can't work all the way through it, don't feel bad. It's a little bit tricky, but get started, give it a try, see what you can do. Okay, so this is what we got. Exciting times happened here, that's for sure. Start by taking the denominators and factoring them. So the first denominator looks like that. The second denominator, excuse me, looks like that, and you've got factor denominators. Then, let me remove my circles here. Then you notice, hopefully, that the x plus 3's are in common for the denominators. That's why they're underlined in green. And that's good, because that means that your new common denominator will be what you had before with just one extra thing. And that's true for both sides, because hopefully you can see that altogether each denominator is now the same thing. So once you notice that, that means the first term you're multiplying top and bottom by x minus 3, and in the second term you're multiplying top and bottom by x plus 3 in order to make things right. So for the first term, the numerator now, you need to actually FOIL out the things you had there, the x plus 1 and the x minus 3. So that FOILs out. And then for the second term, you also need to distribute. It's not as exciting, no foiling, but same basic idea there. Then go ahead and add up the numerators. You've got the denominators the same, so go ahead and add up the numerators. You get x squared plus 4x plus 15 as your numerator. The denominator is that combination of x plus 3's and x minus 3's that we had before. You should look to factor that numerator and see if it's possible, to see if there's any canceling that can happen later on. However, in this case there isn't, so that's the final answer here. Okay, now that we've got that, let's look at number 4. Number 4, in a manner similar to number 3, long, a lot of work to write out. So again, I'm going to suggest that you get a new sheet of paper, or the sheet of paper you worked on number 3 on, and try to work it out there. I do not think you will have a high level of success working it out within the box for the checkpoint here. I will pause a few seconds so you can pause the video, and then hopefully you'll try at least getting the common denominator on number 4, and maybe even punching the whole thing through. Give it a try. Oy vey. Okay, here we have it. Now, first of all, you've got to factor those denominators. So 4x squared factors into 4x and x. Maybe you write that as 2 and 2 and x if you like. The 8x squared minus 12x factors into 4x times 2x minus 3. Common factor of 4x coming out there. And then hopefully you notice pretty quickly that in fact you've got some 4x matching in denominators. So, and I underlined those in green. So the first one, you just need to multiply by 2x minus 3 to have the same thing as what you would get on the second one if you just multiply it by x. Now you see those denominators will be exactly the same. That's great. So you've got to multiply top and bottom by the same things within each term. It's a thing of beauty, although it does look particularly messy at this moment, but it does get a little bit better. The 8 multiplies by the 2x minus 3 and becomes 16x minus 24. Right, so the 8 multiplies by the 2x minus 3 becomes the 16x minus 24. That's great. Now, on the other term, the 2 plus x multiplies by x, and that makes 2x and x squared. But don't forget your friend the minus sign there, so it's actually minus 2x and minus x squared. That second term is entirely subtracted. All right, good stuff is about to happen. You've got this massive numerator over this new common denominator. Reorder it with the x squareds in front. Then I factored out the negative sign. And then I factored it again over here on the right because I ran out of room on the left. You can see that it factors. Now, what would be beautiful is if one of those factors in the numerator matched with a factor in the denominator. But sadly, that is not true right now. So we have no factor love, but at the same time, we've accomplished the goal. So that's it for this particular checkpoint. And now if you look at the rest of the page, you'll see we're actually only a third of the way done with the page. But I assure you the rest of it will go faster. So first of all, we have this idea of a complex fraction. Complex is actually an unfortunate name there because it doesn't mean things with i's and square roots of negative numbers. It just means if you have a fraction within a fraction. It's kind of like a meta fraction. So if you have a fraction in the numerator or denominator. If necessary, simplify the numerator and denominator by writing each as a single fraction. Then divide the numerator by the denominator. The other option is to multiply the numerator and denominator by the least common denominator. Of every fraction in the numerator and denominator, then simplify. The truth is that method 2 is what I like to do personally. I'm guessing you will probably prefer method 1, and so I think that's how the examples are written out. So let's move on. Look at this example 4. Simplify a complex fraction, method 1. Okay, so here we've got a thing, we've got a fraction, right? We've got a main fraction bar. Bloop. And above the fraction bar, you have another fraction bar. You have and below 2. It's a disaster. Fractions of fractions of fractions. It just makes you sad. Here's what you do. Don't freak out. Just go ahead, for example, and look at what's going on downstairs in the denominator. Downstairs in the denominator, you've got two fractions added together. Well, add them together already, right? So it's 15 is your denominator, and you have x plus 5. Ignoring everything else, keep that common denominator. Go ahead and add the numerators. Now, dividing means multiplying by the reciprocal. So it's times 15 over x plus 5. So simplify. Well, here we go. 8 times 15 is, actually don't know, 120. And in the denominator we have 5x and x plus 5. Now there's one more thing that can happen here, because the 120 and the 5, they reduce. You can divide them both by 5, and 120 turns into 24. So, it's really 24 over x times x plus 5. There we go. That's all, finally, for page 3. Thank you for watching.